There's that dang bouncing again with the hands. Don't know why I do it. Just do it. Welcome back. It's a little bit of a snowy day when I'm recording this one. It's 11:24, so a couple days before Thanksgiving when I'm doing this lesson. A beautiful day outside yesterday. Ran outside with shorts on yesterday. I think last night I went with shorts on. Today we've got some snow out there, so a little bit different. I think I just spittled all over my iPad screen. Kind of gross. So today we are moving on to section 2-3, factored form of quadratic functions. So we've already done standard form, or vertex form, standard form, and now we're going to do kind of factored form of quadratic function. So by the terminology and by the title of it, it should be a good determination of what we're going to do today. We're going to factor. Something you put a lot of emphasis on, I know, in Algebra 1 that you took probably back at Ellis, or maybe here with Winter or Pizurich or whoever you took it with here at the high school. But we're going to talk about factoring today, and I factor maybe a little bit different, maybe not. It's easier to judge this when you guys are in front of me. But I do factoring a little bit a different way. I'll kind of explain what I do and how I do it. But I think most of us do it the same way now, so maybe it won't be anything different. If it is, it is. If it's not, whatever. Either way, we're factoring today. So we've talked about the different forms. When we talk about factored form of an equation, let's make this a little bit bigger so you can kind of read it. Factored form, so right there we've got standard form of a quadratic function. Factored form can be written as 0 is equal to a times x minus p times x minus q. Notice it's x minus and x minus, where p and q are what we call the zeros of the function. And we'll talk more about what those zeros mean in just a little bit. The zeros of the functions. What those zeros of the function essentially are is they're the x-intercepts of the graph. And that's what we call kind of the zeros. So the zeros, let's just talk about it now. So the zeros of the graph, when we eventually get there and we get to solving these a little bit, besides just factoring, but essentially what the zeros are is where your graph crosses the x-axis. So if we just got a little bit of a graph, just kind of a little demonstration. If we're looking at a graph of a parabola, and that's what all of these are, parabolas, the zeros for this blue one are here and here. The zeros are your x-intercepts, where your graph crosses the x-intercepts. So you can have two solutions. You could have just one solution or 1 0. So you could have 2 zeros, 1 zeros, or in some cases you're going to have some that have really no zeros at all, and those are the ones that are going to be new. We're going to talk about those in a couple sections down when we start introducing really the complex numbers situation. Got an itch on my leg. The complex numbers situation. So that's essentially what zeros are. You can either have 2, you can have 1, or you can have really no zeros. Today we're mostly going to work with, when we get to it, ones that have 2 zeros. But anyway, you got to remember this general form right here. 0 is equal to a times x minus p times x minus q. That's going to come in really handy when we get to the last couple questions for today's assignment. So to factor, essentially what we're doing when we're factoring is we're kind of undoing the distributive property. We're trying to figure out what this would look like in two parts. And the reason we want to be able to factor is we want to be able to find the zeros. We want to be able to find where these graphs actually intercept our x-axis. So we want to be able to factor. And there's a couple different methods people use for factoring. Some people use guess and check. They say, all right, I know it's going to be something double distribution. If I look at the x, there's an x there, so I know that means I have to have an x and an x. X times x, if I do that, x times x is x squared. The next thing that you can look at is you can look at the symbols. You look at the last symbol. If the last symbol is a plus, both of these are going to take on the symbol that's kind of with your second term. So since we have a plus here, I look at that, and since that's a plus as well, both of my terms in this case I know those both have to be plus. Then we have to get the last term. Well, the last term, if we think about how we kind of do the distributive property or foiling, you go first then you do your outside, then you do your inside, and then you do your last. So that's kind of how that kind of whole FOIL process works, or a better way to say it is the distributive property. That's kind of how that works. I'm going ahead here and rewrite all of this because I didn't want all that on there. Okay. So that's one way. So that's kind of what we're thinking about, is how to do that. So I need two numbers that multiply together to be 12. Well, not only do I need them to multiply together to be 12, but I need to add to be 7. So if I look at the factors of 12, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Those are my factors of 12. I need them to add up to 7 and multiply together to 12. So in this case, it's just 3 and 4. And that's your solution, and you're done. Guess and check method is really what this is. This is how I learned how to do it. And they're really not that bad when you just have kind of one term. When your leading coefficient is 1, when your A value is 1, when it's in standard form. This is kind of really a almost not a preferred method, but when you get good at these, that's kind of the method that you're probably going to use. Another way to do these, and we're going to do the same one again, is what I like to call kind of the X method. And this is the way a lot of the high school teachers teach this, using what we call the X method. So the X method, on the top, we're going to take A and we're going to multiply it by B. A to krumba. It's not A times B, so check, check, check. Okay, so another method that we can use is what we call the X method. And this is a method that a lot of the teachers at the high school use. We're going to make an X. And we're going to fill in the top and the bottom of that X. So the top of the X is always going to be A times C. Your A value times your C value. And the bottom is always going to be your B value. Well, we did this yesterday when we were looking at things that are in standard form. The A, B's, and C's. So in our case, in this one, the A value is 1, the B value is 7, and the C value is 12. So if I take A times B, A times C, A times C is 12. So my top number is going to be 12. The bottom number is B, so my bottom number is going to be 7. So I've got my two top and bottom numbers. Now, the middle, we have to fill it in. So here's kind of the key to that middle part. Those two middle parts, they have to multiply together to be 12 and add together to be 7. So multiplied to be the top number, added to be the bottom number. So 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. So then my factors are x plus 3 and x plus 4. So you get the same answer using this box method. Now, in the case of this question, guessing and checking or doing it however I did that first one, that may be the preferred method, and that might be the way you use. And certainly, if I'm doing ones like this, I don't use this box method. I kind of guess and check and do it kind of in my mind and factor them. Where these are nice, though, is when you start getting something like this. And using the box method is really kind of nice when you have this. Because now, guessing and checking, there's a lot of different combinations that you could have if you're guessing and checking. I mean, you could go 2x and x, maybe it's x and 2x. You look at the symbol there, it's a minus. So if it's a minus and you're guessing and checking, that means one of these has to be a plus and one of these has to be a minus. And now you've got 3 and 1, so they got to multiply it to be 3 and add together to be 1. Well, maybe it's minus 3 and plus 1. And you got to kind of guess your way through and figure out, refoil these and figure out actually which one of these works. And one of them does. But we can use the X method instead. And remember, the top is A times C. The bottom is B. So my A value here is 2. My B value is negative 5. And my C value is negative 3. So A times C is going to be negative 6. On the bottom is my b value, and that's going to be negative 5. So now I need two numbers that multiply together to be negative 6, the top, and add together to be negative 5. Okay, well, negative 6 times 1, negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5, so negative 6 and negative 1 work. So if we do this kind of how we did the last one, we would say, all right, well, then that's x. Let's write an x there instead. That's x minus 6 and x plus 1. Well, here's the problem with this. If I FOIL this out, is that correct? No, it's not. You get x squared, and we have to have 2x squared. So how do we solve that? Well, here's how you kind of solve that problem. Realistically speaking, what we're actually doing is because we multiplied a times c, our a value is 2 here. Essentially, then what we have to do is we have to divide each of these pieces by 2 and then reduce if you can. So this first one reduces to x minus 3. The second one doesn't reduce. So since it doesn't reduce, here's the little trick that you do. The denominator, 2, goes out in front of your x plus your numerator. And there's your solution. Not guessing and checking, a little bit still, up at that top part, you're still kind of guessing and checking. And that's not the problem. The problem is when we get to this part right here, you got to use this little trick. And that little trick is divide just your number by whatever your a value is. So you could go up here and say, we're going to divide this by 2, because that was my a value. And you could do it up there instead, because then you get negative 3, and that doesn't reduce. That's still 1/2. So you get x minus 3 and 2x plus 1. So you do need to be a little careful when you're doing these. Remembering that if your a value is anything other than 1, you have to divide by it. And if you think about it in the last question, I mean, you could divide this by 1, but it's not going to do you any good. So that's kind of the key when you are doing this type of problem, is making sure you are dividing by that b value. Okay, and we'll come back to another example like that in just a second. The next one, you can use the x method to do this. Okay. If you don't recognize it, some of you might recognize it already, some of you won't. What's my a value? Well, my a value is 1. My b value, I don't have one, it's 0. My c value is negative 9. The top is a times c, so negative 9. My b value is 0. Two numbers that multiply together to be negative 9 and add up to 0, 3 and negative 3. So the factor of this expression is x plus 3, x minus 3. My a value is 1, so I don't need to divide by anything. We're done. That's in factored form. The next one. Okay, so now we've got 3x squared minus 7x plus 2. We're going to factor this. Okay, and we're going to use the x method. All right, so generally speaking, when you factor, you got to follow a couple steps. One important step that I haven't really mentioned yet, and I don't really need to mention it for this question yet either, why I haven't really mentioned it, but I'm going to bring it up now. Always make sure when you're factoring, your first thing you always have to do is look for a common factor. If there's a common factor in there, make sure you take that common factor out. So if they're all divisible by 2, factor out a 2. If they're all divisible by 6, factor out a 6. In this case, they're not all divisible by the same thing, and it has to be all of them, so they're not. Top, we're going to go a times c. A times c is on top. 3 times 2 is 6. On the bottom is our b value. In this case, it's negative 7. So I need two numbers that multiply together to be 6, add together to be negative 7. So negative 6 and negative 1. Negative 6 plus times negative 1 is 6. Negative, so that works. So then we've got x minus 6 and x minus 1. But now I notice that my a value isn't 1. My a value is 3. So I'm going to divide by 3 and reduce the fractions if possible. So this one reduces to x minus 2. 1/3 is already reduced. So the 3 is going to go out in front of my x value. minus 1. There's the factored form for that. And box method is really, it does speed things up a little bit, I think, once you get into the habit of using it. Just got to make sure you do that division and then you reduce those fractions. Why does this work? You're going to find out right now. Because what are we actually finding? You're going to find out right now. All right, so the zeros. So the graph shows the function defined y equals x squared plus 2x minus 8. How do the zeros of this function relate to the factors of the expression? So if you notice, they've listed the zeros. We've talked about zeros. Remember that the zeros of a function is the number z, so which f of z equals 0. A zero of f is also called the x-intercepts, which we talked about at the beginning of the lesson. So we see the zeros of this are -4 and 2. Those are our zeros for this. So essentially what we're doing is we're saying, okay, at what point does our function equal 0? And this is called finding the zeros. Okay, we're going to factor this. Well, the leading coefficient is 1, but I'm just going to kind of keep doing this. So if we're asked to find the zeros, really what you're asked to do if it's quadratic is you're asked to factor it and then see what it is. So a times c, -8. My b value is 2, so it's got to be negative, so that means one is negative, one of them is going to be positive. So negative 2 and 4. -2 plus 4 is -8, 2, that works. So this factored is x minus 2 and x plus 4. Now that's going to equal 0. So now we have something that's called the zero product property. And I'm going to come back to this question here in just a minute, but I want to go over something that we call the zero product property. The zero product property states that if the product of a real number's factors is 0, then at least one of them has to be 0. So in the case of two factors, if a times b is 0, then either a has to be 0 or b has to equal 0. So to use the zero product property, we're going to rewrite the equation so that the expression is equal to 0. We're going to factor and we're going to solve. And that's what we did here. We factored it, now we're going to solve it. And what the zero product property says is it says that if a times b equals 0, then either a has to be equal to 0 or b has to be equal to 0. So in here, really what we have right now is we can say that our a value is equal to x minus 2, and our b value is equal to x plus 4. So the zero product property says that if I can make a equal 0, that could be one of my solutions. Or if I can make b equal 0, that's going to be my other solution, or both. But as long as I can make one of them 0, I've got a solution. So if I solve this, I get x is equal to 2. 2 minus 2 is 0. 2 plus 4 is 6. 0 times 6 is 0, so it works. In this case, b is -4. -4 plus 4 is 0. -6. -6 is 0. So my zeros, you'll notice, my zeros are x equals 2 and x equals -4. Look what's up there. X is -4, x is 2. Those are my zeros, where x is equal to -4 and x is equal to 2. So that's where it's going to cross the y-axis. And that's the zeros for these. So anytime you're finding the zeros, you're going to use what we call the zero product property. A has to equal 0, or b has to equal 0, or both of them could equal 0. Okay, so let's look at it. All right, so let's factor this next one. So we've got, graph shows the function x squared minus 9x plus 20. Identify the zeros. So we're going to go ahead and set it equal to 0. So we've got 20 and -9. So that means they both have to be negative. So -4 and -5. So x minus 4, x minus 5. Again, just double check, make sure your factoring is right. Everybody makes errors. Negative 4 times negative 5 is 20, and so it works. So now to find the zeros, x minus 4 equals 0. So my zeros are x is equal to 4, and x minus 5 equals 0, x is equal to 5. So there's are my zeros. You look on my graph, 4 and 5 is where it crosses. So those are my zeros for this graph. So that's finding the zeros. Now let's look at a couple of, there's our product property, we talked about that. Okay, so again, we can solve this. I'm not going to do this one, but make sure when you solve anything that's not equal to 0, in order to solve quadratics, the first thing you have to do is set it equal to 0, then you go ahead and factor. And you could do this one. I'm not going to do this one, but you could go ahead and factor. The next one, and we're going to do this one. So you get 2x squared equals negative 9x plus 5. So the first thing is you're going to set it equal to 0. You always want your a value to be positive. It makes life easier. So I'm going to move everything over to the left-hand side. So it's going to be plus 9x minus 5 equals 0. Okay. A times c is on top. That's negative 10. B is on bottom. That's 9. So two numbers that multiply together to be negative 10. So 10 and negative 1. So my factors, x plus 10 and x minus 1. However, my a value was 2. So since my a value is 2, I need to divide, and I need to then rewrite it and reduce. So this is x plus 5. This doesn't reduce. So the 2 goes out in front of the x, minus 1. Now the zero product property says that each part has to equal 0, so I just kind of think ahead. What's going to make that 0? Well, negative 5. So there's one of my zeros. What's going to make this 0? 1/2. There's my other 0. So essentially you're finding zeros. That's really all you're doing. If you look at this up here, what do you notice about those two things? That's why it works. Because really all we're doing over here is looking for zeros. It's the opposite of it, but it's how it's always been with what's in there. That's why that works. Okay, so we're on 24 minutes right now. So my suggestion to you, I'd hit pause at this point. We've got several more that we're going to do by factoring. We're going to do one more that you like, but I'd go ahead and hit pause kind of at this point on the assignment if you want to. If you don't want to, I guess you don't have to. Well, you're going to have to because I'm going to end the video. And I'd really look at doing the first 12 questions on your assignment and getting those done. And then come back and we'll talk about 17 and 18. We're not actually going to do 13, 14, 15, and 16. So you don't need to do those. But we are going to look at 17 and 18, and I'll do those in the next video. 18 takes a little bit of time. So go do your homework, or don't do your homework.